Hello everyone, welcome to this video on learning mathematics through concepts and examples. In this video, I'm going to show you how you can compute limit using table. This method of computing limit is also called the numerical method. So let's get started with the first example. So here is our first example. Let f of x equal to x cubed minus 9x over 6 times the absolute value of x minus 3. Using the following table to make conjecture about the values of the limit as x approaches to 3 from the left, x approaches 3 from the right, and limit as x approaches to 3. And if it does not exist, you can just write down it does not exist. So here, the table is constructed. As you can see, we are looking for the limit as x approaches to 3. So if you look at the table carefully, what you notice here is these values 2.9, 2.999, 2.999, 2.9999, you can see that these numbers are approaching closer and closer to 3 from the left. And similarly, on the other side, 3.1, 3.01, 3.001, these values are decreasing and approaching 3. So these numbers or these values are approaching 3 from the right. So if you plug in 2.9 into this function, like 2.9 cubed minus 9 times 2.9 over 6 times 2.9 minus 3, we get this one. So that is how those numbers are calculated. So if you look at this table carefully, as we approach closer and closer to 3, the function values are changing. Like we have negative 2.8, 5, 1, 6, 6, 7. Next is negative 2.98, then negative 2.99, negative 2.999. So clearly you can see that these numbers are approaching closer and closer to negative 2.99999 means we are approaching closer and closer to negative 3. So the left-hand limit is negative 3. Similarly, if you look at the right-hand limit, when the values of x are decreasing and approaching closer and closer to 3, look at the function values. We have 3.15 and something, then 3.015, it is decreasing 3.0015, 3.00015. So obviously you can see that these numbers are decreasing and getting closer and closer to 3. So from the right, the limit of that function is 3. So meaning of that is the left-hand limit is negative 3 and right-hand limit is positive 3. So the left-hand limit and right-hand limit are not equal. So the limit does not exist. So the two-sided limit, the limit as x approaches to 3 of the function does not exist. D and E does not exist. So this is how you can use the table of values to compute the limit. And one more time, this method is called the numerical method. Here, the function values were already given to you. So we just look at it. If the function values are not given, you need to plug in all these values into that function and find the corresponding function values. So let's look at one more example. Okay, here we have. For the function f of x equal to x squared minus 2x minus 3 over x minus 3, answer the following questions. So the first thing we want to do is complete the table of values of the function at x equal to a. We have to complete the table of values. We have two little tables given here, and we need to complete that. So for example, if I want to find the value of the function at 2.5, what I do is I plug in 2.5 into this function. So that is like the value of the function at 2.5, which is equal to, we have x squared, so it will be 2.5 squared, and then minus 2x, 2 times 2.5, 2 times 2.5. Then we have a minus 3, so minus 3 over, we have x minus 3, so we are plugging in 2.5, so 2.5 minus 3, 2.5 minus 3. And we can simplify this using calculator. So if we do that, we'll get 3.5. So the first value that goes in the table here is 3.5. Now, what we can do is we can continuously plug in all these different values and see what we get. So let me quickly do that. So I have all these values ready now. So we completed the table by plugging in different values given here. So if you notice this one here, what we are doing is, if you look at the value of A, that is the X values we are plugging in, 2.5, 2.9, we are increasing and we are going closer and closer to 2.999, means we are going towards 3. So here we are approaching 3 from the left. Okay, in the first table, we are approaching 3 from the left. And if you look at the second table, 3.5, 3.1, 3.01, we are decreasing from 3.5, and then we are going all the way up to 3.00001, means we are getting closer and closer to 3 from the right. Now, if you look at the first table, you see that as the X values approaches 3, the value of the function approaches 3.999, means it approaches 4. Similarly, on this side, when X approaches to 3 from the right, the function value decreases from 4.5 and it approaches to 4 again. So the left-hand limit is 4 and right-hand limit is 4. Meaning of that is this limit as X approaches to 3, from both sides, it is 4. So we can say that the answer for the first part here is limit as X approaches to 3 from both sides of that function, x squared minus 2x minus 3 over x minus 3 is equal to 4. So what we did here in part A and B is we make the table to find the left-hand limit or left side limit. This is from left, so this is the left side, and this one, the second one, is from the right side. Okay, right side. So in both of these, from left side and right side, we try to go closer and closer to 3, and we see that the function value approaches to 4. So both left-hand limit and right-hand limit are equal, so the limit exists, and that limit is 4. So we calculated that limit using the numerical method. So this step A and B shows that we have the limit 4, and we use the numerical method. Now, in part C, we are asked to use the algebraic method to estimate the limit. So let's solve the same problem using the algebraic method. So we have limit as x approaches to 3, x squared minus 2x minus 3 over x minus 3. Now what happened is, as x approaches to 3, let's see what is going on here. The first step in computing the limit is trying the direct substitution. So if you try to perform the direct substitution here, denominator will be 3 minus 3, 0. So we cannot have 0 in the denominator. So one of the techniques in this one is try to factor and cancel. Let's see if we can factor and cancel it. So limit as x approaches to 3. If you factor the numerator, x squared minus 2x minus 3, the factors are x minus 3 times x plus 1 over, in the denominator, we have a x minus 3. So we write that. Now here, x approaches to 3. X gets closer and closer to 3. So x is not exactly 3. So x is different from 3, means x minus 3 is not exactly 0. If it was exactly 0, we cannot cancel these. So it's close enough to 0, but these are also equal, so we can cancel that. So what we end up with is limit as x approaches to 3 of x plus 1. So now we get the limit of the linear function. So to find the limit of the linear function, you can perform the direct substitution. So when x approaches to 3, so 3 plus 1, that is equal to 4. So we say that the limit is 4. And you can clearly see that the limit that we obtain from the algebraic method is exactly same as the limit that we obtain here from part A and B using the numerical method. So we can definitely use numerical method to compute the limit of the function. That's all in this video. Thank you so much for watching.